All right, hello everyone. We're in week two. I know this week has definitely been a jump from last week already. A lot of technology, a lot of tables, a lot of very confusing things. Probably one of the most important weeks, though, in the whole term, though, is because it sets the foundation of everything we're trying to do. In this course, standard deviation is a key component in statistical analysis, and everything that we do learn in this course is everything must be normally distributed. And we'll get into further as we get into the course how to prove things are normally distributed. This week we just assume everything is normally distributed, because if things are not normally distributed, then we cannot do the analysis that we're learning. There is other types of analysis that you will learn in other classes if you decide to take them. But for this stats course and for the majority of statistics, everything must be normally distributed or follow a bell-shaped curve to apply the formulas that we're using. And usually if there is a mistake in the real world in statistical analysis, most of the time it's not a mathematical error. It's more they've applied a formula that wasn't allowed. All right. So I'm gonna jump around to a couple problems this week because it's a lot of different concepts, and I really want to show you how to use technology to help, as well as if you prefer how to use the tables, which they will either give you, like in this problem, where it is a little book here that says that icon to view the tables, or you can go and want to say it's page A14 in your book. I put it in the announcement to be sure, but that's where the Z table is in the back of your book if a problem doesn't give it to you. Even though I would prefer you to use technology, and so will Pearson if they don't give you the blue book. But if you just want to use the tables and you get the answer wrong, please just email me. One way to do it, I'm getting a lot of help. If you go here to question help, ask my instructor. If you're having problems, please send it this way versus copy and pasting it into a message, because if you send me this, it sends me the exact problem you're on right now, and I can actually go in and look and tell you, if there's an issue or if the software is just not giving you credit for an answer, because I can override your score. So don't keep redoing a problem if you think you're doing it right and you just keep getting it wrong. Send me this. I always answer within 24 hours. And I'll give you the thing. I mean, when I say 24 hours, usually I answer the same day, but for some of you who like to work late in the night on your homework, which is understandable, I am typically not awake, so I will see your email when I get up around 5:30 in the morning, and that's where I'll try to get back to you. All right, so let's try to do a couple problems so we can see how to use technology. So here, I want you to determine the area under the standard normal curve that lies to the left. That is the key. Anytime we're dealing with normal distributions, if you're using the table, it is always to the left. All right, and if I click on the table, see, hopefully it gives us a picture in this. It does. See here at the area that is shaded? That is what these values inside the table are talking about. It's to the left of your z-score. All right, and if you remember how to calculate your z-score, you can go to the announcements where I have the formulas written out. But it is your value minus your population mean divided by the standard deviation. And I'm going to also, in this week's announcement, attach a PDF to explain what some of these symbols mean, because that is really important. Anytime you get these values, it's ever to the left. Now, what's good to know here is this whole bell curve, the area under this bell curve equals 1, because it's a probability. And probabilities go from 0 to 1. So therefore, all these values in this table, as you can see, are between 0 and 1. If you use Excel, which I have up over here, and we're going to use some Excel here in a minute, Excel's coded the same way the table is. So when you put your equations into Excel for the normal distribution, it is to the left as well. The good news is if you ever have to find values to the right, which there are problems you're going to have to, all you do is you do 1 minus the value to the left, and that gives you your value to the right. Because if I add the value to the left and the value to the right, I will get the answer of 1. And that's how you manipulate this thing. So let's look how to do this problem using both the table and Excel. So I'm going to click on Done for a minute so we can get our numbers. So for part A, it wants me to find the area to the left of the z of a negative 0.11. They've already calculated your z-score, so you do not need to use that formula. So if I go to the table, I just find, let's move this over here, I just find the value negative 0.11. See, this says z, so this is the ones place, the tenths place, and then up here is the hundredths. So we always go to 2 decimal places. So we scroll down, we find 0 0.1, and then we got to scroll back up so you can see this is 0, this is 1. So I'm in the second column. So -1, second column 1. So 0.4562. 0.4562. And see, again, 4 decimal places. 4 decimal places. That's right. Now, if we want to do it in Excel, like if I've been saying in Excel, you type in an equal sign. As soon as you type in an equal sign, that turns Excel into a giant calculator. And the majority of everything we do in this course is already built in Excel for us. So you just start typing when you want to do. So norm, and you can see mine's most recently used because I've done the homework. Norm's dist. We want the one with the S when we're doing z-scores, because a z-score has a, I'll bring it up here so you can see it here. Again, our little bell curved. It doesn't show it on here, but this is centered at 0, and it has a standard deviation of 1. Always. A z, and it's also called the standard normal, and the tables are built off a standard normal, or there is, a standard normal distribution, and that's when you have a distribution with a mean of 0 and a deviation of 1. Well, in Excel, if you put in norms with an S, because normal standard distribution, then it knows you have a mean of 0 and a deviation of 1. So we'll do the second question here. We'll do the first so we can see it's the same answer. And I just put in minus 0.11. You don't have to put in the 0, but if you like to, I'll put it in just so you can see that I typed exactly what it says. Minus 0.011. Enter. 4562. Same answer. So that's how you use technology, Excel, or you can use the table. All right. So I'll go to my next question. You want to do this question? Yes. Save best score because I've already done the work. All right. So here's one. It's a little different. This is where I prefer to use Excel because it does make it a little easier. What do I do? Oh, I click on similar questions so we can get rid of it. So there, the two numbers are the same. So I can go to the table and find negative 1.82. So negative 1.8 over, that's 0, 1, 2. So 0.344. That is the area to the left. But what does it want? It wants the area between these two numbers. So if this is negative 1.82, way over here will be positive 1.82. We have to find what's in the middle. So to use the tables, you're going to kind of manipulate these things because you only know the area to the left, right? So the easier thing to do is find positive 1.82 right here, 0.9656. I'll type that in here, 0.9656. Make sure I got the right number down. Yep. And then I come back up here to negative 0.1, too higher, 1.8012.0344. All right, so there's my two values. Now, scroll up here so you have a little bit of a picture. So we know we're over here at 1.82, somewhere up here, right? And we found the area to the left to be 0.9656. And then we found the area to the left of this to be negative 0.182. Well, what do? We've counted this area twice, so I'm going to just take it out. Well, I forgot to put my equal sign in. That's what, again, turns Excel into a calculator. So the answer is 0.9312. 0.9312. Get rid of that. Now, if you just want to do it in Excel, do just like we did again, equals norms with the S dist, put in 1.82. Now, oops, which as you see, I got 9.656. Bring this over so I can type up here. Minus, then just type it again. If I can spell, norms dist, and put in minus 1.82. And you see I get the exact same answer. And I'll make Excel a little bigger so you can see what I typed in. So I took the positive and subtracted the smallest. So the big minus the small. If you ever get a negative number, you got your values backwards. Your answer will always be between 0 and 1 because we're doing probabilities. So if you ever get a negative number, you probably subtract the smallest from the biggest. If you ever got a bigger than 1 number, you've definitely done something wrong because you can never get a probability greater than 1. So let's move Excel out of our way for a minute. All right. So next. Yes. All right. So now I want to go to question. Well, so here's one. Again, just read the questions. The area to the left, what we've been doing, the area to the right. So this is where you would have to subtract, find this value, the greater one, and then subtract 1 from it, and that's the area to the right, and then you would actually add these two probabilities together because you're going to the left and to the right. Right? So it's a lot of manipulating and really paying attention to words, but how Excel and everything and the tables do it, it's always to the left. So you got to be able to manipulate the questions around. All right, question 7. Okay, click on similar question. All right, now we don't have a mean of 0 or a standard deviation of 1. Right? We have a mean of 50 and a standard deviation of 7. So the first thing it wants us to do is pick what is greater than 40. So this is a greater than sign. So we come down here. This says, here's 40, but that's the left. That's less than, right? Because what's over here is 30, 20, 10, so that's a less than, so that's not right. Here is 40, and it goes on forever, so that's greater than. And here's one that says between 40 and 50, because we stop at 50. But 60 is also greater than 40, so therefore, this isn't the right answer. So B. So by drawing out a picture on your paper before you do a problem really does help solve the problem, because it lets you know what you're looking at. And you can see this is a final check. So if you get it wrong, you got to redo the problem. All right, so that's greater than 40. Now, it wants me to find the probability of greater than 40. So here is where you have to use the Z formula. So this value is our X. So if I put equals X, which is 40, minus the mean, which is 50, you want to put it in parentheses, because if you don't, because of order of operations, the computer's going to, or your calculator, whatever you do, is not going to give you the right value. So put it in parentheses, and then you're going to divide by the standard deviation, which is 7. And there is your Z score. So Z equals that value. So then you just do like we just did in the previous problems. Go to the table, find this value, and then you'll get a probability. However, remember, our table is going to give us this value. We want this value. So when you find your answer, you need to subtract it from 1. So we'll do it real quick so you can see. So let me bring my Excel over so we can continue to see that. Negative 1.42. So negative, well, make sure I rounded, that's right, because that's an 8. It's actually minus 1.43. 1.40123. 0.0764. 0.0764. There's the value from the table. That's to the left. That would have been our answer if we would have highlighted A. But because B, we're doing greater than, we have to do 1 minus that answer, 92936. 0.9236. I said the numbers wrong, sorry. 0.9236. 0.9236. Check answer. Now, this is why I like using technology. That whole formula, the Z formula, is so you can use tables. We have technology now. We don't actually need to use tables. We can just use technology. So we've been using norms dist. And if we use norms with an S, dist, we have to have a mean of 0 and a standard deviation of 1. That Z formula converts things over for you so you have a mean of 0 and a deviation of 1. However, there's another function in Excel called norm dist without the S. And you can see we have to put a lot more information in. We must put in the X, which is 40. We must put in the mean, which is 50. We have to put in the standard deviation, which is 7. And it says cumulative. Cumulative means add all together. This is all shaded. So yes, we're adding it all together. And for all of these, the answer is always going to be 1. And you see, I got 0.0764 because Excel does just like the tables. However, because we know we have to subtract it from 1, I don't have to redo anything. I just put a 1 minus in because we're doing greater than. And we get the answer of 0.9234. Yeah, so this is going to be a little bit lower. So it should work because this is actually accurate, unless I've done something wrong. Let me make sure I got my numbers in there right. Here is the issue between the tables and technology. Because this Excel is 100% accurate versus the tables which have rounding because they only can go so far. So let's round this thing to 4 decimal places. Oh, too far. 4. Yep, so you can see there is a hundredths of a difference. Of course, I already put my answer in, so I don't know if it'll let me redo it. Need a bigger screen so I can have both windows open for you all. Shrink this down a little bit more. If it doesn't take it, that's when you question help, send it to me and say, hey, there's something wrong. And one of you have already done that, and I've responded back to you and stuff. So, oh, good. Give me the exact same thing again. So let's try it again. Let's see if it takes my Excel answer. Final check. And continue. And then Excel is 0.9234. And it took it. So there we go. Good. It took both because they're both correct answers if you use the table that they gave you or use technology. I know this can be extremely frustrating as a student learning the material for the first time. I agree. I really wish we would just get rid of tables and we would use technology. And I know a lot of you email me a lot like, well, I like to do things by hand. I really think you need to use technology because if you ever do apply this outside this classroom in your field of study, you're not going to do things by hand. You're going to use computers. You're going to use technology. You want to be able to find the results. Your data is just going to be way too large in the real world to do things by hand. So I want you to use technology and understand what these things mean. All right, so get off that. Now let's go to another question. We'll go up to 11. Because here is where we start talking about the central limit theorem. So basically the central limit theorem, every problem up to now is you're selecting exactly one out of a sample. Now, what happens if we select more than one? That's what the central limit says, right? The central limit theorem says we can apply the central limit theorem if we have a sample size greater than 30 or we're selecting from a normal distribution. Everything you have done up to now remains the same. All right, so for part A, yeah, we'll hit similar question again. Suppose the lengths of pregnancies of a certain animal are approximately normally distributed with a mean of 224 and a standard deviation of 18. What is the probability that a randomly selected pregnancy lasts less than, that's the area to the left, of 217 days? Perfect. I have to now do the Z thing, use my Z form like we did earlier, where this is 217 minus 224 divided by 18, right? And then I can go to the table. See, there's no table here in this case. And this is one where a student emailed me, and the table and Excel were different. I don't know if it would have taken the table. I explained to him, though, if he wants to keep using the table, send me a picture screenshot to your ask your instructor, and I'll override the grade if the table input is correct. But here, I'm just going to use Excel. So equals norm. I'm not using the one with the S this time because I have a mean and standard deviation. And I just put in X is 217. Our mean is 224. Our standard deviation is 18. And we always put in 1. There's our answer. 0.3487. 0.3487. Make sure I put that in there right. 3486, but that 7 rounds up. So 3487. Now, read part A again. What is the probability that we're going to select pregnancy? So what they don't have here is a 1, but we're only selecting a pregnancy. Here, we're selecting a sample of 15. 1 to 15. Now I must apply the central limit theorem. Well, the central limit theorem says the mean of the population and the mean of the central limit theorem are the same. So that doesn't change. What does change is our standard deviation. Our standard deviation of our population is 18. Our standard deviation of our central limit theorem says you take standard deviation and you divide it by the square root of how many counts you have. So our new standard deviation will be equals 18 divided by square root of our samples, 15. And there's our new standard deviation. Now we do the exact same problem we just did a minute ago, but instead of using a standard deviation of 18, we're going to use this standard deviation, 4.64. And why I like Excel, You see, I just clicked in and it automatically said, I'm going to go to that cell and take that value. I don't even have to retype the value in. I can just type it in there. Hit enter. And now you can see my probability changed a lot. 0.0660. 0.0660. And then part C, same thing, except for what we do. We change the sample size. So to change the sample size, I come here, and instead of doing 15, I do 36. And notice everything changed automatically because I said call this cell. And if you set Excel to do up to this, and you make these neat little quick spreadsheets, this is how Excel can be your friend, and you can get things done really quickly. It does take practice, and that's why I'm trying to make these videos to kind of show you these kind of tricks. All right, I know we've been going for a while here, but we're going to go one more question. I know a lot of questions this week, but we covered a lot of material. I'm going to go to question 13. Because now we are doing based on P. So everything up to now we have done everything based on the mean. The two concepts that will stay throughout this entire course until we get to kind of regression at the end, but up to regression, we're going to do two types of analysis. We're going to do analysis on the mean, mu, and we're going to do analysis on the proportion P. Well, if you look at the little PDF sheet that I've attached here, well, I'll bring it up. It'll take 2 seconds here because I need to attach it anyway. Let's see, M240. No, that's the syllabus. That's not what I want. Statistic symbols. I'm going to post this to this week's announcement real quick. But here's all the values you're going to see in the formulas. And you can see right here, mu, which is a Greek letter, is the population mean. Sigma is the population standard deviation. And then P is the proportion or probability of the population. Those are based on populations. Then we scroll down and we have a P hat, which is the sample proportion. We compare P hat to P. Sometimes you'll see 1 minus P and Q. All Q is 1 minus P. So if I put a Q in a formula, that's 1 minus P. So Q is the what we call failure of the population, where Q hat is the sample failure. And then we scroll, where are you at here? Did I already go past them? Oh, they're up top. X bar, which we learned last week, is the sample mean, and S is the sample standard deviation. So I'm going to have this sheet. I highly encourage you to print it out so when you see the formulas, you can go through and put them in your own words. And this will be attached to today's announcement. Get rid of that. Close that. So, describe the sample proportion of P hat. Well, there is some rules first. First, we got to look at our requirements, right? And here they are, is approximately normal if n, little n, which is our sample size, is less than 0.05 of big N, which is our population. So here, population of 25,000. Multiply that by 0.05, and your sample must be less than that. And 600 is less than 5% of that population. And N times P, so 600 times 0.8 times 1 minus P, which would be 0.2, has to be greater than 10. So if you wanted to check these, just go into Excel and check them. So 0.05 times big N, which is 25,000, equals 1250. 600 is less than 1250, so therefore I've met the first rule. Second rule is N, which is 600, times P, 0.8, times 1 minus P, or Q, which is 0.2, is 96. 96 is greater than 10, therefore we are good to do this analysis. These are the checks you have to do. First it asks what they are, and this is in the announcement, these checks. So all I have to do is make sure you have your notes handy and saying, yep, I verified these are true. Now, again, based on the central limit theorem lesson, determine the mean of the sample proportion. Well, the mean of the sample proportion is just equal to P. So the answer is 0.8. Just like before, the mean of the sample central limit theorem is the same as the population mean. What does change is the standard deviation. All right. So to find that, which is a formula in itself, and I don't have it written down, so let me give me 1 sec to bring up my notes. That's why you also get notes, because this formula I don't memorize. Where? Did I put it in here? I know I tried the page number, page 416. I must have put it in the earlier week's announcement. All right. Well, here we go. Another way I can show you how this can help you. If you don't remember, you can click on textbook, and it'll bring you to the part of the chapter that this problem helps you with, so you can look at the book. So there we go. We'll go there and get the formula. So if you do forget it or didn't write it down like I didn't do, you just click on the textbook, and hopefully your internet's faster than mine. I do live out in the woods in Maine, so my internet is kind of slow. But that help button in StatCrunch can be very useful when you get stuck. The tutorial, the videos can be really good. I like going to the book because it can help me make sure that I have everything I need here. So here is what I said, p-hat. That's how you find it. Right here. There we go. Sample distribution of p-hat. There's the rules. So page 416, just like I said in the announcement. The mean of p-hat is equal to p. The standard deviation is p times 1 minus p, which is q, divided by the square root of n. So, let's see here. Use our Excel, equals square root, parentheses, p, 0.8, times 0.2, divided by n, which is 600, close my parentheses, 0.016. Which is what I have typed in, 0.016. All right. So, a lot in this video. We covered a lot of material. That's why I made a little longer video, did a few extra problems. Because this week, as I said, it is very important. It builds the foundation of everything we're going to learn. We're going to keep applying everything that we learned from this week to everything we're going to do with different ways of doing the analysis. As I said, until we get to regression, which is week 6 and 7, we're always going to do analysis on the mean and the proportion. So the quicker you can kind of understand what these symbols mean, or at least have the attached PDF that you can read it, the little easier it will be besides the technology piece. And I will keep creating videos to help us kind of see how to use technology to kind of help with the calculations. All right, enjoy week 2. I will be online. Please email me if you have any troubles, and I will talk to you all again soon. Have a good day.